8.4 notes, distance, midpoint, and slope. So we're going to talk about 3 different formulas, and the first one is the distance formula, and the distance between 2 points is used by using the distance formula. So it's the measure of length of a line segment connecting the 2 points. You can never use the distance formula for a line, but you can for a line segment because it starts and stops. And it's d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And x sub 1 and y sub 1, x sub 2, y sub 2, those are just going to be the values of the coordinate point that was given of the line segment. The next one we're going to talk about is midpoint. So midpoint, it's a point on a line segment that divides the segment into 2 congruent parts. In this formula, you add the x's, divide by 2, and you get the new x value. The y value, add the y's, and divide by 2. Because it's a midpoint, your solution and the equation is a coordinate point. And last but not least, slope. We know that's going to be telling us the steepness of the line. Change of y's over the change of x. We've talked about this before. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Here's example 1. We have to graph the following line segment and by the points and find the length, the slope, and the midpoint. So if we have point P, which is negative 1, 5, I'm going to plot that. Sorry, my graph is not perfect. I don't have graph paper. And Q, so I'm going to label it P, is negative 1, negative 2. So based on that, I'm going to draw the line segment so I can see that it's a vertical line. Cool. Now we have to find the length. So in order to represent the length, it's PQ. And remember, in order to find the length, we're going to do the distance formula. I'm going to label this one x sub 1, y sub 1, x sub 2, y sub 2. And then using the distance formula in our example beforehand, x sub 2, negative 1, minus x sub 1, a negative 1, so it changes it to a plus 1 squared, plus y sub 2, negative 2 minus 5 squared. So that's going to be negative 1 plus 1 is 0 squared, so that disappears. Then you're left with negative 7 squared, which is the square root of 49, which is just 7. And if you wanted to, you could have counted, because it's a vertical line, the number of units from P to Q, and it is 7. Good. Now we're going to find the slope. So I'm going to do a little lowercase m. Change of y's over change of x. So negative 2 minus 5 over negative 1 minus a negative 1, so it changes it to a positive. So we have negative 7 over 0, which makes it undefined. And last but not least, the midpoint, which is a big capital M. You're going to add the x's, x sub 2, negative 1 plus negative 1, divide by 2, and add the y's, negative 2 plus 5 over 2. And you're going to get negative 1, 1.5 as the midpoint. And if you plotted it, negative 1, 1.5, and you labeled it point M, you should see that point M is in the middle of points P and Q. Our second example, this time we have to graph the following 2 line segments, AB and XY, then find the length, the slope, and the midpoint of each of them. So we're going to do the same stuff that we've done before, but we're going to have to do it with 2 line segments for this problem. So I first am going to find the length of each. So here's AB and here's XY. So I'm going to square root of x sub 2, 4 minus a negative 2, so it's plus 2 squared, plus negative 3 minus 5 squared. That's going to simplify to 6 squared plus negative 8 squared, which is going to be 36 plus 64. Remember, if you're going to enter negative 8 squared into your calculator, you have to put the negative 8 inside parentheses. 36 plus 64 is the square root of 100, which is just 10. Awesome. Now we're going to do the same formula for xy. Square root of x sub 2, negative 3 minus 5 squared plus negative 2 minus 4 squared. So we have the square root of negative 8 squared plus negative 6 squared, which is the square root of 64 plus 36, which is the square root of 100, which is, again, 10. Nice. The next thing we're going to do is find the slope of AB and the slope of xy. Again, change of y over the change of x. So we're going to have negative 3 minus 5 over 4 plus 2. It's going to be negative 8 over 6, which simplifies to negative 4 thirds. Good. We're going to do the same idea with xy. So negative 2 minus 4 over negative 3 minus 5. We have negative 6 over negative 8, which becomes a positive, because a negative divided by a negative is positive, 3/4. The last bit of information we have to solve for is the midpoint of AB and the midpoint of xy. So again, I'm first going to do AB. You add the x's, so 4 plus negative 2 over 2, comma negative 3 plus 5 over 2. This becomes 2 over 2, so it's going to be 1. Negative 3 plus 5 is 2 divided by 2, which is 1. Good. The slope of xy, add the x's, divide by 2, add the y's, divide by 2. So we're going to do negative 3 plus 5 over 2, comma negative 2 plus 4 over 2. And this time you get 2 over 2, which is 1, and 2 over 2, which is, again, 1. Last but not least, we have to analyze our information. So what conclusions can you make? So we've used 3 different equations. So at each equation, we have to come up with an information. So our first one, we said that the distance of AB was 10 and the distance of xy was 10. Since these are the same, we can say our first conclusion, AB is congruent to xy. Because their distances are the same, we can say that they are congruent. This little symbol means congruent. Statement number 2, we talked about slope, so we either know that the lines are going to be parallel, they're going to be perpendicular, or they're going to be neither. Since these slopes are opposite reciprocals, we can say that line segment AB is perpendicular to line segment XY. And last but not least, since the midpoints are the same, we're either going to say that they bisect each other or they don't. Since the midpoints are the same, we're going to say AB bisects and XY bisect each other.